let us solve this step by step. Each shutter forms a right angled triangle. We mean that by if we drop a perpendicular from Q to meet the horizontal PR at somewhere here, we can form a right angled triangle. So let's try to do that. So this line, the right angled, this Q will meet the horizontal somewhere X. So we could find the distance PX. Then we could also drop a perpendicular from S to meet the horizontal line PR at somewhere, let's call it K. So if we could, for example, get PX and somewhere KR, we can find easily QS, because if we join Q to S, we are forming something like a rectangle or a square. So which means that QS will be equal to XK. So our main interest should be to get the distance between X and K. So consider the right angle triangle PXQ. We can get PX by using cosine, which means that cos 63 will give us the adjacent side, which is PX, divided by the hypotenuse side, 1.8. This means that PX will be equal to 1.8 times cos 63 degrees. Therefore PX will be 0.8172. We can also take triangle, right angle triangle KRS, and try to get KR. So again, we can use cos 63 degrees is equal to KR divided by 1.8. So that gives us KR equals to 1.8 multiplied by cos 63 degrees, which again gives us the same answer, 0.8172. So we can say that the horizontal distance PR, if we close down the shutter, is 1.8, which is PQ, plus 1.8. So the horizontal shutter PR is 3.6 in total. So if you want to get the distance XK, it is the total distance PR minus the addition of PX and KR. So XK is equal to 3.6 minus, when we add these two, PX and KR, we get 1.6344. Therefore XK is 1.966 meters. Clearly we say that XK is equals to QS, because that's a square. Therefore QS will be 1.966